Today we're going to be talking about probability uh, that corresponds to observational data and comes from a table of counts. This is quite common in many situations, but we're going to consider the following table that shows the status of cancer, that they have it, it's true. If they don't have it, it's false. And if the individual was a smoker or not. So in this data set, for example, there are 300 individuals that are smokers and that also have cancer. Okay, um, so so the table represents the counts and the values of the variables cancer and smoker. In this case, true and yes. For our first question, we're asked to calculate the probability of cancer. There's two ways that an individual can have cancer. They can be a smoker and have cancer, or they cannot be a smoker and have cancer. So the total number of individuals is going to be 300 plus the 100. And if we were to calculate totals for the rows and the columns, we get something that looks like this. So I'll call this totals, and this will also be totals. So there will be 400 here, there will be 600 here, 600 here, 400 here, and a grand total of 1,000 for the interior. That represents how many participants there are. So there are 400 individuals with cancer out of 1,000, so that's 40%. Okay, so the column totals, when you divide them by the grand total, they represent the probabilities for the columns and likewise for the rows. So the probability that someone is a smoker, well, we just go to the row total for cancer being yes, and that's 400 out of 1,000 again, and that's 40%. Now, if we want to calculate the probability someone was a smoker and had cancer, and I want to emphasize here this and, okay, then where we have to look is to the 300, the upper left-hand column. Both values need to be satisfied. So for that and, there are 300 over 1,000, that's 30%, are smokers and have cancer. Now, for the next probability, it's the same values, but one thing changed. It's an or, so we can use the general addition rule. So this will be the probability smoker is yes, plus the probability that cancer is true, minus the probability of both, that they're a smoker, and so smoker is yes, and cancer is true. Okay, so if we were to do this, this will be 40% plus another 40%. And sometimes people forget to subtract the intersection. But here, if you do that, you're going to get a probability that's too high. So we need to subtract this 30%. And what we're going to get is 50% from the general addition rule. Okay, now for the last one, it asks us to calculate the probability that cancer is true, and here the keyword is given. So it's a conditional probability, and how we calculate conditional probabilities is we're going to calculate the probability of both cancer is true and smoker is yes, divided by the probability of smoker. being yes. Okay, so we know all of these probabilities. We know that the probability of being a smoker is 40% of the population in the study. So that's 40. The probability of both is 30%, so 3/4. And so the probability is 3/4 or 75%. Okay, and there we calculated the conditional probability. Now, this question asks, are cancer and smoker independent? Well, there's an easy way to check that. One way is just with conditional probability. So the conditional probability that cancer is true, given, and given can be represented with that bar, given that they are a smoker. So smoker equals yes. Okay, we found that to be 75%. The question we need to ask, is that equal to the probability of cancer being true? And we know from our previous calculation that for the overall population, that is 40% from our very first calculation. So it's not equal. And this says that if your status of being in the group of smoker changes to yes, your probability of having cancer being true changes to 75% compared to the general population of 40%. Okay, so the answer is no. The events are dependent. That is, the smoking status affects the probability of cancer. Okay, and that's what it's asking there. You could also calculate and verify this another way with this formula and check that cancer being true and smoking being yes is not equal to the probability of cancer being true times the probability of smoker being a yes. And I'll leave the second one as an exercise, but it will also show that they are dependent events.